Hi friends, welcome to my channel. Let's have a look at problem 2582, pass the pillow. This problem actually is very elementary, so we're going to use this problem to explain modulo operation in mathematics. So the statement is the following. There are n people standing in a line labeled from 1 to n. So the first person in the line is holding a pillow initially. So every second, the person holding the pillow will pass the pillow to the next person. So once at the end of the queue, you can understand this as a queue, then the pillow reaches the end of the line, then the direction changes. Then the people continue passing the pillow in the opposite direction. So here is an explanation. So the problem asks, given two positive integers n, the number of person and the time elapsed, so we're going to return or find the index of the person holding the pillow after this 10 seconds. So here are some two examples. So if n equals 4, time equals 5, then the output is 2. And when n equals 3 and time equals 2, so it reaches the last person. So here are some constraints. First, n is greater than or equal to 2. So this is an important one, right? So the upper bound can be very large, actually. So here time is greater than or equal to 1 and can be very large. So here it's bounded above by 1000, but it's not necessary. So with that said, let's look at the analysis. So as we mentioned, we are going to use a modulo operation. So the observation is the following. So for example, if you have like in example 1, so you have four people. Let's vary the time to see what's the pattern. So we have 1, 2, 3, 4, 5. So this is the number of persons. Then if time equals 1, so you pass the ball from person 1 to person 2, right? If time equals 2, so you pass from 2 to 3. And if pass is 4, you pass from 3 to 4. If time is 3, you pass it from 3 to 4. And if time is 4, you pass from 4 to 5, the last person. So notice that, so if the number of persons is 5, then there are 4 gaps in between, right? 1, 2, 3, 4. Then n people, let's generate like this. So n people, you will have n minus 1 gaps in between, right? So then if time equals n minus 1, the pillow will reach the end of the queue, or you can say the pillow will be holding by the last person. Then if you continue increasing time, for example, time is n. So if time is n, right? So then the pillow will from person n to person n minus 1. So if n plus 1, then it will be from n minus 1 to n minus 2. But if you reverse it, again, it has n minus 1 gaps, right? So in other words, if time equals 2 times the gaps, right, then the pillow will reach the first person. Again, it will reach the end of the queue, but in the reverse direction. So to summarize, so if we do modulo operation, so here you can understand that if time is a multiple of this number, then it will arrive at the very beginning, reach the initial state. So we are going to use time equals time modulo this operation. So 2 n minus 1. So if time equals 0, right, it's of course the initial state. But if time is greater equal than 1 and less than or equal to n minus 1, so the result will be 1 plus time, right, like here, right? So if time is further larger, it's greater than equal than n and less than or equal to 2n minus 1. So actually it's strictly less. If you write like this, the result will be something like this, right? So here minus the first round, then we want to compute how many gaps back towards the beginning of the queue. So this is the main arguments. So now let's look at coding. So once you understand the reasoning, so this coding part is rather straightforward. So let's do temp modulo operation is 2 times n minus 1. Let me just use a if else, right? So if temp equals 0, so we just return 1, because here we are using 1 indexing. Otherwise, if temp is in this range, less than or equal to m minus 1, so the answer will be this one. So result, let's return 1 plus temp. So here actually is this less than or equal to. All the other case, so because the remainder will be in between 0 and 2 times n minus 1 minus 1, right? All the other case, it will be something like this. So this will be 2n minus 1 minus temp. Return 2 times n minus 1 minus temp. So let's check that. So run the code. It passes the one of the example. Now let's look at the generic case. Yeah, it passes all the cases, right? So that's basically about it for the current problem. So if you like, maybe you can see some similar questions, right? So to practice. So with that said, I guess that's about it for this easy problem. Thank you.